All right, pull out the worksheet. Spent 2 days on the idea of polynomials and some basic ideas of polynomials, zeros, some terminology of polynomials, degrees of polynomials. Solutions were posted. Any questions, anything you need me to go through with respect to the polynomials? Once again, a lot of this gets reflected right back to you. You keeping up with the material. Okay, I'm going to provide opportunities for you to have success in here, but you have to be able to come towards me a little bit and get the work done. I'm not sitting here looking to see if you have your homework done or not. That's on you guys. Questions? Anything you need me to go through? Multiplicity. It's nothing difficult, it's just learning some new terminology. It's things that, a lot of the stuff is things that we've done already. It's just we've renamed them into something different. Alright, continuing on with polynomials, today we're going to evaluate polynomials, look at the evaluation of polynomials, how we could do that using what is called synthetic division. And then we'll deal with some division of polynomials with the use of synthetic division. If we have a polynomial, 4x to the 4th plus 5x cubed minus 7x squared minus 4x plus 10. I ask you to evaluate this polynomial at a value of 3. Well, my x value is a value of 3. So I'm asking you to evaluate 4x to the 4th, or 4 times 3 to the 4th, plus 5 times 3 to the 3rd, minus 7 times 2 squared, minus 4 times 2, plus 10. Go ahead and evaluate it. Clickety-clack it to your calculator. Up and down the bunny trail. Yeah, should be 3, I guess, up there, not 2. Should be a 3. And a 3 there. Check your hands with somebody around you. That is what you come up with. 394. Which is correct, I guess, say so, if everybody agrees to it. You have 394. Probably run into is, if some of you had newer calculators, I would inevitably use my caret, take it to the 4th power, forget to use my right arrow to pull out of my exponent, and then continue to clickety-clack through 5x cubed, and then I would have a very long exponent because I forgot to pull out of the exponent. Okay, I don't like that feature with respect to the new TI calculators where you have to hit your right arrow to pull out of that. Okay? And if we have the negatives there, sometimes we run into some difficulty with the negatives because we take negative, if we would have negative 2 squared to the 4th power, I take negative 2 to the 4th, I forget to quantify the negative 2. We run into issues then. So there is problems with using your calculator, you just have to be very careful with it. So what we have is we have other ways of being able to evaluate polynomials. Some of it is because back in the old days, there's no calculators around. Students didn't have calculators with them. They didn't come to class with a calculator. Okay? They had to do everything by hand. Well, what one way is of doing by hand is called synthetic division or synthetic substitution. Does anybody know what the term synthetic means? Synthetic. Well, synthetic is, you have synthetic turf, you have stuff like that. Synthetic, if you break it down even further, it just means man-made. Man-made substitution. And the reason why we man-make them is because it's probably too difficult in another way. So we find ways to make it easier for ourselves. Why? Because we're humans. We're humans. We want to find an easier way to do things. Why? Because that's in our DNA. Why we have cars. Why we have bicycles. That's why we don't ride around on horses anymore. Okay? So, we make things to make things better. We have heating units. We have air conditioning units. Okay? We have lights. Why? Because we didn't want to light a candle. Okay? So, man-made, synthetic, is a way to make life a little bit easier for ourselves. Well, if we take a look at what occurs here. When I take 4x to the cube, this is 4 times 3 times 3 times 3 times 3. We're multiplying by 3 4 times. Then we're multiplying 5 by 3 times 3 times 3 3 times. Minus 7 times 3 times 3 twice. Minus 4 times 3 to the first, and then we're just adding 10 in there. So when they broke this out and what they were doing, they decided to make what is called synthetic substitution to make life a little bit easier on ourselves. In synthetic substitution, we put a little half box out front. And the value that we are subbing in, we're subbing in the value of 3. Along the top, we are writing the coefficients 4, 5, negative 7, negative 4, and 10. Now, we have to go in decreasing order to our degree. When we're dealing with synthetic division. So our degrees have to be in decreasing order. And if we're missing one, we need to put a 0 in there to hold the place value. We draw a line. Put a finger space in there. Don't do it right underneath the numbers, because we'll write in that area. Have you seen this before? Have you done this before in algebra? All right. Okay, if you remember what we did, we dropped the 4 down. And then we diagonally multiplied by this value here. So we multiplied by 3. So we have 12, and then we add down. to give us 17. We diagonally multiply by 3 to give us 51. We add down to give us 44. We diagonally multiply by 3, which gives me 132. We add down to 128. We diagonally multiply by 3. Oh, let's see. 84, 384. We add down, and lo and behold, Ali Kababa, Shishkumpa, we have the value of our polynomial. Now, why does this work? Why does it work? Well, if we take a look at the 4, we had to multiply it by 3. So we multiply it by 3 here, 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 4 times. The value of 5, even though it doesn't look like 5, we multiplied by 3 times. Because where did we get the 17? Well, this was 5 plus 12. So we multiplied 3 times 5 and 3 times 12. 3 times 5 is 15, 3 times 12 is 36. Add together gets me 51. So even though it doesn't look like we multiplied by 4, well, how did we get this? This was, how did we get the 4? Well, we got the 12. We had 4 times 3. So here we have 4 times 5, which is this 5, and then 4 times 3 times another 3, which gives me the 12. So we are multiplying by the values of 3, 4 times, 3 times, 2 times, and 1 time. So we're still doing what we did up here, but it looks a little bit different. Numbers are a little bit smaller. Go ahead and evaluate the value of 6 and evaluate the value of -2. Check your answer with somebody around you. Kristen, what do you get for 6?
5,998.
Good with that? Marissa, what do you get for -2?
14.
Value of 14. You good with that? Okay, so thanks, substitution, not very difficult to do. You can check this if you wanted to by using your calculator and evaluating it through your calculator at that point. But when I ask you to find the value on a quiz or on the worksheet, I want you to use synthetic substitution. The second part of the day is dealing with division. If I had the value 8,769 and I want to divide by 21. By using long division. Go ahead and divide it out. Oh boy. Fond memories of 4th and 5th grade. Long division. Were we over here in the middle school, the new middle school then? Or are you guys down at the old middle school still, 4th and 5th grade? What year did you move up to here? Our year. So you're what grade? Fourth grade? Yeah. Division. Don't want a decimal either, I want a remainder. What do I do with the remainder? Don't put just an R there. What do we do with the remainder? Your brain hurt. Decimals. What do we do with the remainder? All right, take a look at some cues here. Okay, we sit there and first off we have to see, does 21 go into 8? No. So we take 21 and goes into 87. Brooke, how many times to go into that? 4 times. So we put a 4 up here. Then what do we do? Okay, so let's slow down here. Okay, how do we multiply by 80? How do we multiply the 4 times the 21? We go 4 times the 1. That gave me a 4. Then 4 times the 2. That gave me an 8. And then what did you say we did?
Subtract down.
We subtract down. So if we subtract down, we have 8 minus 8, which is 0. And then we have 4 and 7, which gives me 11, correct? Why doesn't it give us 11? Oh, so I have to go 8 minus 8 and then 7 minus 4?
Mm-hmm.
Oh. Are you sure?
Yeah, I'd say I'm pretty sure.
Okay, that's fine. Just double, oh my legs are so big. So you're saying we come down to a value of 3 here. All right, we get a 3. What's our next step then, Isaac? What do we have to do?
Bring the 6 down.
Yeah, we trail the 6 down. Boom, and bring it down to here. Then we ask ourselves, so, how many times does 21 go into 36? Jordan, how many times?
1 time.
1 time. So we can put a 1 up there. We multiply 1 times 1, which is 1. 1 times 2, which is 2. And we subtract, and do we get 17? So I get confused by this stuff. So we get what? What should we get there? You sure? Alright, we'll make this small this time. So you're saying we get 15. Alright, that's fine. And our next step, what do we do, Preston?
You drop down the 9.
Drop down the 9. And then ask ourselves, how many times does 21 go into 159? Now, what was the little key to that? What was the little trick that we used, or you used to see how many times 21 goes into 159? Didn't have a calculator there. What would you do? Anybody remember what you did? Huh? Well, what you could do is see how many times 2 goes into 15. 2 goes into 15 how many times? 7 and some change. Well, I just want the 7. And that was a good starting spot up here. So I have 7 times 1, which is 7. 7 times 2, which is 14. We subtract, and are you sure we don't get 116? Well, I get 9 and 7 and 16, and then, oh, that should be 916. There we go. My bad. Sure we don't get 916? All right, that's fine. I'm just checking because I miss out on some things sometimes. Okay, so we subtract down, and what did we come up with, Marissa? 12. Now, what do we do with the remainder of 12? Yes, we continue to put a decimal there if we wanted to, but if I just have a remainder, I don't want to just put R12. What else could we do with it?
Don't you put as a fraction 12 over 3,000?
12 over, not 8749, or 6,
21?
huh? Over 21. Whatever we divide it by. Yeah. You can take 3 out the top and bottom, give it 4 7s, and that would be fine. So, let's go to the next one. Now we're going to divide a binomial into a polynomial. Now, what we remember, if we take a look over here, what we did from left to right here, we got rid of digits. Okay, the H went away, we had nothing left there. Okay, we eventually got rid of the 1s here. Okay, so we continue to get rid of digits as we went to left to right. And that's what we want to accomplish up here. Okay, we want to accomplish getting rid of terms from left to right. Well, just like we used a little trick here, how many times does 2 go into 15, we can use the exact same thing up here. Let's see how many times x goes into 3x cubed. How many times does x go into 3x cubed? Because what we're going to want to do is we're going to want to eliminate terms from left to right on our radial dial. Okay? So how many times does x go into 3x cubed? Just 3? I'll take the 3. 3x. We're taking 3x cubed and dividing by x. 3x squared. Okay? X goes into 3x cubed, 3x squared times. So our next, what do we do over here next? We slowed our brain down, and that's what I'm trying to get you to do, is slow your brain down. Okay? I multiplied the 4 times the 1 to give me 4, the 4 times the 2 to give me 8. That's what we have to do over here. Okay, so let's multiply the 3 times the x, which will give us the 3x cubed. And then we have 3x squared times negative 2. That gives me what? Negative 6x squared. Okay? All we're doing is we're multiplying by both of these terms. Just like we multiplied the 4 times the 1 and the 4 times the 2. We have to multiply the 3x squared times the x and 3x squared times the negative 2. Alright? Same idea. Trying to parallel what we did here. Next thing we do is subtract. When we subtract, what do we come up with? No, what'd you come up with? Negative x squared. Because these terms cancel out. 3x squared minus 3x squared, it gives me 0. Okay, they cancel out, and that's what we want, just like the 8 and 8 cancel out. Okay, be very truthful and be very honest here. Show of hands, how many got the negative x squared? Raise your hands up. Oh my. I should take a picture. You guys didn't get negative x squared? Well, what all you guys just proved to me. You know what you just proved to me? 87 minus 84 does equal 11. Thank you very much. You guys laughed at me. When you said 87 minus 84 and I wrote down 11, and oh, he doesn't know what he's doing. He's old, he's seen now, he's trying to lose it. Okay? He's trying to lose it. He's cuckoo for Cocoa Puffs. You just proved to me that 87 minus 84 is actually 11. And 159 minus 147 is actually 916. Yes?
I'm very confused.
Well, what was our next step? What did we have to do? Jordan, what did we have to do? What did we have to do in this step here? What did we have to do in this step? How'd you get, you didn't get negative x squared. What'd you get?
I was just thinking it was going to be a room change because of the minus and negative, but
What'd you get?
11x squared.
Oh, you got 11x squared. Well, when I'm subtracting here, what you told me here, I had to subtract 7 minus 4 to give us 3, correct? And then 8 minus 8 to give me 0. You told me that's what you had to do. So if we go over here, if I'm subtracting, I need to make sure I subtract both of my terms. So I got a negative 3x squared, and then we got our boom ching there to give me 6x squared. Very good. So my answer here is actually 11x squared. Thank you for proving me right. That 87 minus 84 is actually equal to 11. You proved it to me. Thank you. I just love this lesson. Because all you guys are really, really smart. You're really smart. You're really smart. But sometimes you think, oh, we're good. I like to bring you down just a little bit. Yes?
I'm so sorry. I'm just really confused and I feel kind of dumb. But how do you do 3 minus negative 3 and get 0? Or is that just like distributed?
Well, I distributed the negative to both of the terms.
Okay.
So I got a negative 3x squared cubed and then a positive 6x squared.
Got it. Thank you.
Better now? Alright. We've eliminated the 3x squared, or 3x cubed. Next thing we need to do, well, what do we do over here? We trace down the 6. So we're going to trace down our next term, a negative 7x. How many times does x go into 11x squared? Maybe? How many times does x go into 11x squared? 11x times. So we have plus 11x. Then we multiply to both of our terms. So we have 11x squared and a minus 22x. We have to subtract an entire bottom. Basically, what my frame of mind is when I do this is I need to change both signs. Change both of the signs. So when I distribute the negative to both of these terms, both the signs, that's a negative and that turns into a positive. So now I have 11x squared minus 11x squared gives me 0. And this gives me 15x. We trace down to 9. How many times does x go into 15x? Angelique, how many times does that go in? 15 times, so I have a plus 15. So we have, let's see, 15x minus 30. I subtract, and if you want to, just change both of your signs to give me 39. That is our remainder. So we have our plus 39 over what we divided by, x minus 2. Let's do this one over here. Let's take our 2x plus 1, divide it into 8x to the 4th, plus 6x cubed minus 7x squared, plus 2x plus 4. Okay, do your long division. Check your answers with somebody around you. So if we take a look here, how many times does 2x go into the 8x to the 4th, Preston?
It goes into it.
4x cubed times, so we multiply, gives me the 8x to the 4th plus a 4x cubed. A lot of room for a lot of mistakes in here. We have to subtract, so we change our signs, they're both negative. So when we add down then, it gives me a 2x cubed. Okay, once again, common mistake. If you have a 10x cubed there, you didn't change your signs. Okay, once again, 87 minus 84 is actually 11. Okay, 2x goes into 2x cubed. How many times? That
2x squared.
2 goes into 2
That'll be x squared.
plus x squared. So we multiply, that gives me 2x cubed plus x squared. We gotta subtract, we need to change our signs, which gives me a negative 8x squared. Bringing down your plus 2x. See, 2x goes into negative 8x squared. How many times though? 2x goes into negative 8x squared.
4x
Minus 4x. So then we have a negative 8x squared minus 4x. Need to change our signs. Gives me a 6x. Then 2x goes into 6x 3 times. Bring it down to 4. Once again, a lot of room for little mistakes here. Let's see, it goes in 3 times, it gives me 6x. Let's see, that gives 6x plus 3. We had to change our signs, so we have a 1 there. Hopefully I didn't do any mistakes. Once again, a lot of room for little mistakes here. We'll work with synthetic division tomorrow. I have a worksheet. I gave you a worksheet. You'll be able to do problems 1, 2, 3, and 4 on the worksheet. Tomorrow we'll work with synthetic division, and then you'll be able to complete the second half of the worksheet. Once again, only do problems 1 through 4 on the worksheet for the homework tonight. Questions? QED, as done.